Hello everyone, myself Dr. Feroza Demirajkar, and today we will see a 8051 program to transfer 10 bytes of data from the internal RAM to internal RAM. Okay, here I have written the RAM spelling wrong. It is RAM. RAM. Okay, sorry, it has been written as double M. The purpose of this program is to copy 10 bytes of data from the memory address 30H to 40H. These are the steps of the program which we'll be using to write the program. Here first we will initialize the loop counter and the pointers. Then we will use a loop in order to transfer the data byte by byte, and we'll halt the operation, that is, we'll stop the operation when the program is completed or when the data is transferred from 30H from the memory address which is starting from 30H through 39H to the memory location starting at 40H through 49H. So here I have taken the data. These are the 10 data which are being stored at the memory location starting from 30H to 39H. That is, at 30H we are storing 11, at 31H we are storing 22, at 32H we are storing 33, and so on up to 39H. At 39H we have 0AH. So these are the data which you are seeing in the box and boxes, and here these are the memory locations, okay, for this respective data. So this is before execution. Now before execution at 40H, okay, at memory location starting from 40H through 40 up to 49H, all the data is 0, okay, yet we have not transferred the data. This is before execution. Now after execution, what happens is this data is present in 30 in memory location starting from 30H to 39H. So after execution, the same data, it will be copied to these memory locations starting from 40H to 49H. Earlier these all data were 0, but after executing the program, you will get the data which was present in these memory locations. It is being transferred to the memory location starting from 40H to 49H. Okay, so here the data which is present in 30H, it will be transferred to 40H. That is 11 is in 30H, so it is transferred to 11H. Sorry, 40H. Then similarly, 22 is being transferred from 31 to 41. Then 33 is transferred from 32H to 42H, and so on up to 39H. That is the data which is present in 39H, that is 0A, it is transferred to 49H. So this program will undergo 10 iterations, okay, because it has to transfer 10 data like this. Okay, each time the pointer will increase the memory locations here. Okay, now we'll see the program. So here org0000H, this directive, it will set the starting address of the program to 0000H. It is where the program begins to execute. Okay, now next is move R2 #0AH. This instruction, it will load the value 0A, that is 10, into the register R2, and this register, it will act as a loop counter in order to transfer 10 bytes of data. Then comes move R1 #40H. Okay, so here this instruction, it will load the value 40H into the register R1, and this register will serve as the destination pointer pointing to the memory location where the data will be copied. Next comes the loop, this loop. Okay, this is a data transfer loop. Here for this loop we are using the label as up. So the first instruction here is move A at R0. This will indirectly move the data from the memory location pointed by R0 into the accumulator A, and this reads the source address. Okay, this will read the source address. Then next comes move at R1 A. This will indirectly store the content of the accumulator A into the memory location pointed by R1. So this will writes the data to the destination. Okay. So here this instruction, it will read the data from the source, and this instruction, it will write the data to the destination. After that, we will increment the R0 register. So R0 earlier it was 30H, now it will become 31H. Then we'll increment R1. So R1 was 40H, now it will become 41H. DJNZ. So this is decrement R2 by 1. So here if R2 is not 0, it will jump back to the label up. This will ensure that the loop executes 10 times in order to copy the 10 bytes of data. So here now R2, earlier R2 was 0A, now R2 will be 9. It will decrement it by 1. So R2 will be 9. Now it is not equal to 0. Therefore again it will jump to this label and it will execute this loop. Then when it executes this, here R0 will become what? It will become 32. This will and R1 will become 42 and R2 will become 8. Earlier it was 9. Now it will become 8. Again it is not equal to 0. So it will go again back to, it will jump to this loop label and again it will execute this loop. So it will execute the loop 10 times until and unless this R2 becomes 0. Once R2 becomes 0, then it will go to the next instruction. And here once all the loops are completed, uh, here it will enter a infinite loop here. Okay, h colon s jump h, it will enter a infinite loop and it will effectively halt any further action. So this is a common way to stop the program execution in assembly. And next is the end directive. Here it will mark the end of the program and it informs the assembler that there are no more instructions to process. Okay, so before execution, 30H, okay, will be having at from the memory address starting from 30H to 39H, it will be having these data. And 40H, the memory address starting from 40H to 49H will have these data, that is it will be 0. After execution, the data which was present in uh, the memory address, that is the memory address starting from 30H to 39H, it will be transferred to the memory location starting from 41H to 49H. So you can see here earlier 40H was having all the data was 000. Okay, and here the data is being transferred to the memory address starting from 40H to 49H. So this is the step-by-step execution of the program. Here first step is to initialize the counter R2, then the source address, okay, that is 30H R0, and the destination address R1 is equal to 40H. Next we'll start the loop. We'll enter the loop here. In the loop we'll read the value from the address 30H, that is R0, in the internal RAM and store it in the accumulator. After that we will write this value to the address 40H, that is a destination address, that is R1 in internal RAM. Then we'll increment R0, okay, to point to the next byte in the internal RAM of the source, and then we'll increment R1 to point to the next byte in the internal RAM of the destination. Then we'll decrement the loop counter and this loop will continue to execute 10 times because we have initialized R2 is equal to 10, and this will execute until and unless R2 becomes 0. So there will be total 10 iterations. Once these 10 iterations are completed and R2 becomes 0, then it will enter the infinite loop at the level H. Okay. Now we will see the execution of the program. I'll copy the program here. Now we will open the Keel software. So maximize it. Go to project, new Mevision project. I'll select Alice, which I've created previously. Yes. Then search the device microchip. Click on this plus symbol and search for 8089C51. Okay. Then click on OK. Then click on No. Now target is been created. Go to file, new file, write your program here and save it. Okay, I'll write this as into int. It is internal to internal. You have to save the program with .asm extension. So save. Yes. Now click on the plus symbol of the target. You will get source group 1. Right click on this and click on add existing files to group source group 1. So now type your program name here. It is internal to internal, that is into int.asm. Click on add and close. Now go to project, build target. So there are 0 errors and 0 warnings. Then go to debug, start or stop session. Debug session. Okay. Now already we have memory 1 window here. So it is internal to internal. So we will be typing here I:30H. We need one more memory window. So I'll take from here. Memory 1 is already being used. Now I'll select memory 2. You can take the memory window from here also, from view. Okay, here memory window is you will be having. You can select either from this directly, or you can go to the view and you can select the memory windows from that. So in memory 2 we want the destination address. So it is I:40H. Okay, now here we will enter the data. I'll write 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 and 10, that is 0A. Okay, these are the data which I have entered, that is this is the input data. Now I'll go to memory 2 and I will see whether here at these locations, that is starting from 40H to 49H, whether my data will be transferred. So go to debug, then click on run. So you can see here the data has been entered, that is it has been changed. Earlier it was 0000000. Now it is 1 2 3 4 5 6 7 up to 0A. So in memory 1 we had given this as the input. So in memory 2 the data is being transferred, that is it has become 01 up to 0A. This is how you do the program, 8051 program, to transfer the 10 bytes of data from the internal RAM to the internal RAM. Hope you have understood the program. Thank you.